Hi ETL enthusiasts, welcome to this presentation related to Informatica interview perspective, real-time project discussion about the workflow design part 2. Earlier we have discussed the real-time project part 1. This is the continuation of that presentation like a sequel. That was Bahubali 1 and this is Bahubali 2. Let's start the music. Okay. Let us try to recap what we learned in the previous presentation so that second part will be understandable. As you all aware from the last presentation is that I am the CEO and managing director of this Jaffa Bank. This is called I Hate Corporate, which deals with accounts, financial and banking transactions worldwide. So it also deals with this is the current we're talking about my Jaffa Bank, I Hate Bank accounts, savings, deposits, current equity data, and check-in data. And also this bank deals with the loans, home loan, personal loan, and vehicle loans, and also commercial and corporate loans, which is also in business with the contracts, debt, and derivatives. I have a I have a greedy board of directors who always thinks that they must double the money every year. Okay, so this I Hate Corporate also has multiple other entities for that I hate. I hate loans, I hate finances, I hate enterprises. These all our transactions are also included called internal parties. And also we have some external parties which have a contract between internal parties and external parties. Transactions are also coming for this corporate. So our requirement is to create a enterprise data warehouse to understand the business and take the decisions to improve the business to get double the money. As I told you, I have a greedy board of directors. So how come these enterprise data warehouse get the data? What is the source data for this one? So first one is I Hate Corporate system, which is the base system for the I Hate Corporate. All the data must be present in I Hate Corporate system. That is central system or mainframe systems we have. After that, we will deal with the monthly transaction database, Netissa, and Mongo database for master data management, and C data, customer data from Salesforce, loan processing system, that is Teradata. We get the data from Teradata loan process system, and I have big data daily transactions which comes from Hive, and I have CDS JSON files. This is contract data source, and also currency and country data which comes from ISO website, and also foreign exchange rates which comes in XML, FX rates. So those are the source systems that I have which gives me data for this project. Okay, so project called I Hate 360, that is enterprise data warehouse. This is the high level design of the project. Sources, so there are 9 or 10 sources we have from where we get the data and then put it into a stage tables. That is the first step, that is I360 stage table. After that we use the IDB, that is integrated database or integrated data hub, which is the relational system which maintains at least 1 month of the history. Stage doesn't maintain any history. ETW is nothing but one dimensions and one fact, so it has all the ETW. That is the next step. So there are 3 steps. One, extract the data from source to stage, and stage to IDB, IDB to ETW. That is our high level design. There are downstream users or end users for the integrated database also. Instead of they go for individual sources and combine them, they will get the data from IDB itself. So only last 1 month data, transactional data is enough for them. They don't want a history data because they are not taking any decision from the this data. That's why they don't bother. But from EDW, it will be 5 years of history, and they will the end users really wanted to analyze the data for the past years, and then they wanted to increase their business into expand. They want to expand it, and they wanted to double the money. Let us come to this presentation. Workflow design 1, we're talking about the prerequisites. What are the things that we need to do before workflow design? Okay. Workflow design 1 prerequisites are load windows. We have to find out what is the load window and the dependencies between the source systems and the data, understanding the data basically, and end user requirements, what they wanted, and when they wanted the data to be available for them, and error handling, how do you handle the errors. Okay, let us see one by one. This is the load window. What is the load window we're talking about here? So let us take an example. I hate corporate system is there, which is Oracle database. At 9 a.m. the transaction starts for the day, for the business day, some 12/04/2022. A transaction happened, customer opened a new account, or customer transaction happened, they debited an amount, or they credited some amount. There's a transaction, so that transaction will be in Oracle. Second transaction he did at 10 a.m. Another customer changed his address, so that is the next transactions we have. And at 12 p.m. one of the customer, or many of the customers, we don't know, right? At particular 12 p.m. we have multiple customers changed their add-on card, so they have added new person to the card, so they will get a new card now. Likewise, all transactions will be done and put it in this IHCS system till 5 p.m. of that particular day. That is the business day we call. Okay, so all these customer data or transactions will be loaded into IHCS. Okay. This is I give a sample one. Okay, there are so many other transactions will also happen between 9 to 5. That is the business day end. Okay, even after end of the 5 p.m. sometimes source system does. Okay, let us see what is the load window. Load window is nothing but a fixed time which source system allows us to extract data from the system for the business day. For example, a head corporate system usually ends its business day by 5 p.m. EST and uses another 1 hour till 6 p.m. They will do some adjustments to the transactions that have done. Maybe by mistake they did something else and they just wanted to adjust in their ways. And the other manual activities will also happen till 7 p.m. Say for example, they are taking the backup of their database. At that time, no, they don't want to disturb their backup schedule, so that they won't allow any system to extract the data from there. So, source system here or product owner allow us to take data from that system from 9 p.m. So they have 1 hour buffer, 7 p.m. to 8 p.m. They just kept some of the buffer. If the activity is delayed, then 9 p.m. will be right time for them. So they will advise us to take the data from 9 p.m. and 11 p.m. because after 11 p.m. they just want to do something else also. So on a daily basis, IHCS allowed you to extract the data from their system from 9 p.m. till 11 p.m. EST. Did you get the point on the load window? So this way on all our source systems, we go to the product owner, the source system owner, and we'll have an agreement, okay, service level agreement, that they have to make this data available every day without any issues. Okay, that we will take an agreement from the every source system owner. That's the load window. Let us look at it. Next one. We're still discussing the prerequisite, the second point, that is dependency, identifying and understanding the dependency. Let us take an example, better understanding. Daily transaction big data hype gives us daily transactions of each and every account. Like an example, customer ID, customer code, customer name, account ID, transaction amount and transaction date. Okay. So ETL code usually comes from data mapping specification document, which clearly says how to load this data. Customer ID, say for example, customer ID must be present in IHCS before it loads into table customer data table. Okay, column customer identifier. So these columns names must not be same. The source system might be using customer ID, whereas our system might be using CSD identifier. Okay, so here data mapping specification clearly saying that you have to look up into IHCS database table and find out whether this customer ID 12345 is present or not. If it is present, then it is a successful transaction. You will put it into our tables. If it is not, then it's an error saying domain lookup error. Okay, what do you understand here? The same way. So data mapping specification clearly says customer take the customer ID and try to check in the um, IHCS system. If it is present, then it is a good transaction. So this transaction has dependency on IHCS. So what do you understand? IHCS must load before this daily transaction big data should go into load. Right? You got the point? So first data load should happen is IHCS. Otherwise, what will happen? IHCS is not loaded, but your daily transaction is getting loaded. Then what will happen? Customer ID 12345 into go into lookup and then check in IHCS table, which is not present. The customer ID is not present. Then it will be an error and it will not go into a fact table or dimension table. That's the problem. So that's where the dependency comes in. So you have to find out. And also another example is country data and currency data. If today's countries or currency data is not loaded, we got some transactions with a different country which is not present in the customer lookup, then there's a problem. So that's where the dependencies comes in. So dependencies helps you to schedule sequentially what are dependents you have to load first and then what are the independent items which can be loaded later or parallel. That is the second point in the prerequisite. Let us see the third point here in the prerequisite. That is the end user requirement. Okay, let us understand what end user wanted. So end user requirement by when. So what end user saying is that by when all data for the business date, whatever date we were discussing earlier, the data he wanted to analyze, by when it will be available for them to analyze the data, right? Example, end users, a board of directors wants to see the data and analyze the data before they come into the office by 8 a.m. next day, right? They come 9 a.m. next day. So they wanted the data to be available by 7 a.m. so that 2 hours of the buffer time will be available. If any issues are coming in, unknown issues are coming in, then that can wait till 9, right? That's why they will give the time. That is the end user requirement. So ETL load has to complete by 9 a.m. EST and then reports can run off within 2 hours by 7 a.m. so that data will be available as reports to end user. Buffer 1 hour for any unexpected errors or delays. So data has to be available by 8 a.m. EST so that they can analyze further. Let us get into the next slide. We are still in prerequisite, the last point we're discussing. Error handling. This is a very important topic for the project. Every source system data may have errors. So error handling definition is important. So business analysts, architects for the project will be analyzing the data earlier before getting to your system and calculate the percentage of errors and decides what to do. Usually, 4 types of error checks can happen or advised in required columns. A column from source which can form a primary key or a composite key column check. Foreign key column check. If any column is coming from source we are using for a foreign key, then it should not be null. Domain key, lookup key errors. That means if any currency key coming from source which is not present in the currency table, then there is a problem. Say for example, manually somebody included currency as IND, whereas INR is the Indian currency, then it will fail, right? This transaction will go into error. And the last one we'll check is what are the important column values that has to be present, but it is not coming from source, is null values. Check. So these are the four types of checks we usually advise it to check. So these are the error handling things we do. So what do we do with these error records? Do we load it or not? It depends on the requirement, basically. Because source system maintains the data, that means it's active. I mean, it's a good transaction, right? If you are thinking it's a bad transaction, then there's your problem, right? So that's why while creating our requirements or while creating our project requirements, the analysts and architects will analyze the data and then see what data they wanted. They don't want error data, then they don't take it. Likewise, they will decide and let us know. So we don't need to worry about that. Okay. So below can be decided on the project requirements. So load all errors into a separate file, source system wise, and then send an email to the end of the load. After end of the load, they will send an email with that saying these are the data we are getting erroneous from your system. Can you please have a look? At the same time, it will also be sent to BA team, business analyst and data analyst team for further checks. If it is from production, they have to immediately look into those errors and then they have to correct it and then send it back tomorrow. Okay, load all this data into a table. The second scenario is that these error tables will be created separately for a source system and then put these errors into that table. Let source system have a look and change the data to feed tomorrow. So if any errors are there, we will inform the source system. Source system will come and check the data and then they will correct the data in the table itself so that we can extract the data tomorrow while extracting source data. Load all these errors. Third requirement may be load all these errors into target tables with specific default values. So for example, currency code is coming as null, but from source side it's a valid transaction, and our business analyst will decided that we need this data, don't discard, because if you discard it, then between source and transactions and EDW, the count and amount may not match for a quarter, right? That's why they wanted to keep this transaction, but they don't want a currency value to be null. So what they do, they will be defaulted to UNK, that is unknown values. So it all depends on how the requirements have been written in the data mapping specifications. Let us get into workflow design. Okay, what are the available sources for this project we have? So IHCS, ISO country currency data comes in, foreign exchange data comes in, customer data, daily transaction data, monthly transaction data, master data, and contract data source, loan processing data. These are all data we are getting it on a daily basis. Stage is how we can load the data to be considered stage 1, mapping 1, which loads the data from source into a dump tables, also called pre-stage tables. That means as is. We load as is. Okay. Stage 2, mapping 2, load the data from dump tables to stage table, adding our business required new columns and then load into stage tables. Third mapping is load the stage data into integrated database or integrated data hub databases. And after that, stage 3, mapping 3, load the data from IDH and stage load into the dimensions. Stage 4, mapping 4, load the data into fact tables using IDH, IDB database as well as staging tables and load it into fact tables. Mapping 5, load the data from fact into aggregate fact table. Okay, this is how we design workflow. So stage 1, mapping 1, why we need dump tables is also a question, right? If you have a staging table already, why you want a dump table, right? So 5 p.m. is the end of the business day. Until 7 p.m. manual adjustments happen. Load window given as 9 p.m. and 11 p.m. Say for example, with our server is down and you wanted to extract the data after 11 p.m. The problem, right? So that's why first we'll simply dump this data, and 9 p.m. itself we'll simply dump the data into our staging pre-staging or dump tables so that we don't go to a source system again. That's why this dump is needed. Okay, got the point or no? Let me tell you it again. Load window is 9 p.m. 11 p.m. If we miss because of the server issues after 9 p.m., then problem, right? They may not be allowing till 11 p.m. and our transactions load will be getting delayed. What we do at 9 p.m. is our jobs are started. At 9:30, our jobs are failed and server is down. Between 9 and 9:30, we could have loaded the data into dump tables, and then we're saved, right? After that, stage mapping can run. We don't need to go to source system again. That's why load windows are very important. We have to load the data at any cost within the load time, so that we don't break the SLA that we have. Okay. Let's get into the next slide, that is flow diagram. Let us see the flow diagram of the workflow design. We're in the flow diagram section. Before going to that, I wanted to recap it again to understand how we create a flow diagram. Okay, so here if you see sources, we have 10 sources. This is project I hate 360 for Jaffa Bank. So there are three steps here: stage load, IDB load, dimension and fact loads. Okay, this is our project that we are creating a workflow here. Okay, let us see the flow diagram first before we going into the actual design. Data flow as per the plan are: step 1, data from source file or database table has to be loaded into pre-staging tables or dump tables. You know why, right? If source system send files, then no need of dump tables, because we are having that file anyway, and at any time you can simply load them. You don't need to worry about the SLA. Okay, we load directly into staging table. Okay, if we have files. Step 2, data from source file or pre-stage tables directly we load into the staging tables by formatting, cleansing and adding project related identifier columns into staging tables like create date, load date, source system ID, like that, and date formatting. Pre-stage, dump and stage tables are always truncate and load. That means they don't maintain the history here. Only one particular day's data will be present in there. Because we don't want to maintain any history in the staging table also, where we are already maintaining in EDW. Then load the data from staging into IDH or IDB tables, error handling also included in them. Then load the data from staging IDH tables into EDW dimension tables. Load data from staging IDH tables into EDW fact tables using the lookups as dimension keys in the dimension tables. Because in fact table, dimension keys are to make the composite keys, right? So note here is integrated data hub or database won't maintain all history, but can maintain last 1 month data. See, if it is also maintaining the all history, then there are so many performance issues happens, because we are maintaining an EDW, which is normal. It is a partial normalized structure, which is actually the structure for EDW, enterprise data warehouse, and which maintains a lot of history. So you don't need to maintain in the transaction database. This transaction database is to load for only 1 month of data, so that our downstream users who wanted to extract the data from different source systems, instead of that consolidate them, it is available as a single source of truth. So that's how it is. Okay, so that all the data for this department can be available as single source for the related data. Example, billing data. Okay, let us see the flow diagram here. In a step, source system tables, pre-staging tables. From source system we load into pre-staging. From pre-staging to staging, staging to IDB tables and staging to EDW dimension table. Using EDW dimension IDH tables we load into fact table using EDW dimension tables. That is the final diagram to easily understand. Let us see the table structure, how the tables will look into in the IDH as well as EDW database. This is IDH database tables. It may be different, formatting thing in a table name conventions. Okay, depends on the project, but here is the example: T underscore project name that is I360, and then customer, account, time, contract, loan, foreign exchange, address, branch, currency, country, country relation table, because you must know, right, which currency for which country. That's where you have country currency relationship table. And also the transactions, which is daily and monthly transactions. Okay. After loading this IDH table, we have EDW tables. It is also depending on the different structures. I mean, naming conventions you can decide. Sometimes it will be D underscore I360 or dim underscore I360. Sometimes we call T tab underscore I3. It all depends on how they decide. Architect will decide, right? Table names. So TI is 360, dim customer, dim time, dim currency, dim country, dim address, dim branch, dim foreign exchange, fact revenue daily, fact revenue monthly, fact aggregate revenue, fact balance daily, fact balance monthly, fact aggregate balance. These are the facts that we have for this project. Okay, this is how the table structure. Note, every table load is happens from different mapping and different sessions. Okay. Next slide. Workflow design. Let us get into workflow design. How do we design, right? Now we know the dependencies and how to handle the errors, and we know the end user requirement and load windows. Let us get into the workflow design now. So IDH workflow. So source-wise workflows have to be created. This is workflow design one. So we'll create source-wise workflows. Say for example, we have IHCS workflow, which has 3 steps and 3 worklets. That is pre-stage worklet, stage worklet, IDH worklet. And also we have daily big data hive workflow, which gives us daily transactions, which also have 3 worklets: pre-stage worklet, stage worklet, and IDH worklet, and etc. So 9 different workflows, each have 3 different worklets. 9 into 3, 27 worklets are available, and 9 workflows we are going to create. Okay. So this is what the project I am showing it again. We have sources, 9 sources. So, and these are the steps we have. As first step, stage, IDB, and IEDW. Okay. Next one is dimension workflow. Okay. Dimension workflow, party and customer dimension, currency country dimension mapping, bank branch dimension, customer address dimension, time dimension, account dimension, contract or loan dimension. These many dimensions we maintain. Okay. In IDH workflow, it's like pre-stage. I have to dump the data from source system tables into pre-stage workflow. So pre-stage tables, that's why we have say for example 10 sessions are there, then I will create a worklet, separate worklet. Likewise, we load into stage IDH also, right? So those were. And dimension workflows are like this. These are not source system wise, it will be like dimension wise. Now fact workflows. Revenue fact, balance fact, revenue monthly aggregate fact, deposit fact, deposit aggregate fact, balance fact, balance aggregate fact will also be there. Okay. Let us see the workflow design. So I have 3 steps as I told you. So every workflow has 3 steps: pre-stage worklet and stage worklet and IDH worklet. Okay. This we are talking about IDH workflow. Sorry, IHCS workflow. So from source we load into pre-stage worklet, and then from pre-stage database we load into stage database, and then stage to IDH worklet. Okay. So this is the 3 steps we see in the project, right? So that's what decided here. So once pre-stage worklet completed, we'll go with the stage worklet. After stage worklet complete, IDH worklet will go. Okay. That is the workflow we design. as part of this one. Okay, we have multiple ways of creating a design. We will discuss in the second part and third parts too. Okay, this is integrated data hub workflow design. Okay, so this is currency and country workflow, which can start at 8 p.m. because the actual transaction and IHCS can start from 9 p.m. as per our load window. So before that, we need the data to be present are currency and country as a dependency, right? Country currencies are independent; they can load it first. And second one, which has an independent one, is foreign exchange rate. This is not account basis. This is a rate on the particular date, the currency exchange rates. So these two has to be present before we go into the IHCS. So before load window, say load window 9 p.m. it has to start. So before load window, if we have a time and we have the file source files already, we'll go ahead and load the currency country workflows and then foreign exchange rate workflows. We'll get the data into first so that lookups will not have any impact on the IHCS workflow. And we have another source system here, which is also similar structure as it's designed with our architects. So that is nothing but C data, customer data workflow, which SLA is 9:30 load window. We can extract the data from 9:30. So by 9:30, IHC workflow should complete. By 9:30, we'll get started. Okay. And there's a loan process workflow too. At 10 p.m., we got a load window, and then we have scheduled the workflows in this way, in this manner, so that they can go sequentially without any issues. Here's the EDW workflow design. We have loaded IDH data, so we are looking at dimension load first. Okay, dimension also has stage workflow, stage worklet, and has also dimension worklet, which is totally called a dimension workflow. Okay, so the dimension workflow, which can handle all the different dimension data and will be loaded first before fact load starts. Okay, after IDH completes all source system data integrated into integrated database, then only this process will get started, maybe around 12 a.m. Okay, and then we have fact workflow here. In this workflow design, first workflow design, we're doing all IDH is source system based workflows, and here we have one workflow for dimension workflow, one workflow for fact workflow, one workflow for monthly workflow, one workflow for aggregate workflow. This type of design we did here. Okay, this is monthly fact workflow, and we have aggregate fact workflow too. Okay, this is our aggregate fact. Okay. So in this way, if load happens, then by 3 a.m. we are completing that, right? So as we have designed workflows here, let's start writing some advantages and disadvantages of this design. Okay, that can be discussed in the third part. Okay, until then, that's the end of the discussion, folks. Thank you very much. Have a good one.